Hey there, kids. Welcome back to another lesson with your Eureka Math. Just in case you're looking for a specific video, today we went over how to search on YouTube for a specific video if you can't find it. You have to spell setness probably close to correct. Put in module, M-O-D-U-L-E, whatever module you're on. We happen to be on 1. We were talking about which lessons we were covering yesterday or previous videos. It was lesson 1. Today it's lesson 2. And so if you put in the module and the lesson, it should show you the video right away. Also, if you're looking for something else like a special video that's like a preview before lesson 1, I have the introduction to place value. So we are in module 1, lesson 2, and the objective is to reason abstractly using place value understanding to relate adjacent, meaning right next door, base 10 units from millions to thousands. It's handy if you have a place value chart. This one is just from the book, and it's in a little paper protector, and you can use whiteboard marker and just erase right on this thing. And so you can kind of practice and erase, and if you make mistakes, it's a real easy fix. So keep that handy if you need it. That's just an easy way to use it. So just for the beginning, of course, I've got some notes for you. So this is to kind of connect the old way to the new way. So there are some good warm-up activities in the teacher's manual that we will do in my class, but your teachers may not do it. See if you can skip count by 2s to, say, 40. Can you skip count by 3s to 39? And can you do these things forward and backward? That's a really important skill. Can you skip count by 4s to 40, forward and backward? Do those things for practice when you're not working on the video. Another skill that comes up in this lesson and future lessons is to decompose whole numbers. If composing means building and putting together, decompose means breaking them apart. This is the very first part of what this Eureka Math kind of introduces, and they use it throughout the program. When I first started doing it, I thought it was kind of crazy because I said, nobody ever talks like this. Nobody ever uses this. You won't see this in any other math except 5th grade math. But if you do understand it, it really does help you kind of with place value and a lot of other math concepts. So taking something like 83, the number 83, calling it 83 ones, just so that you can show you understand place value. Break it then into 8 10s and 3 1s. Then do that with these numbers. Pause the video while you practice that. And then another skill is to bundle and change units. It's kind of challenging, but you can use the place value chart, again, this little thing here, to kind of help you see if I do have 10 hundreds, why is this like that? And it's basically because we have a base 10 system and you cannot fit more than 1 digit per place value column. And so you can't have 10 hundreds necessarily in this column, although we will, what I call put the squeeze on later in the year as we decompose and bundle these numbers differently. But why would we not do that, or why can you say this? It's because the 1 would get bumped over to here. So if you have 10 times 100 or 10 hundreds, then you would get 1,000. Now the shortcut thing that I'm always looking for is, how do you know you can get 1,000? Well, 1 times 1 is 1, and then we've got 1, 2, 3 placeholders in these zeros, and so when you multiply, it's going to be multiply the whole numbers and then count how many zeros and tack them on. That only works with whole numbers. As soon as you have decimals, it doesn't work anymore. I'll show you why. Also keep your place value chart handy. There's the PV. So here's your whole number, 367 times 10, 3,670. 367 divided by 10, shift it the other way. Okay, whole number times 10, there you go. Whole number divided by 10, same thing, shift the other way. Watch out. Here's where the change happens. If you're working with decimals, you cannot just add a 0 if you multiply it by 10. Can't do it, don't do it. You'll mess up every time. It's the shifting of the digits. A lot of your parents will say, just move the decimal. A lot of students have said that too. And yes, you will get there, but it's easier if you just understand about where the digits are going. We can move the decimal later when you have a little bit more comfort about where you place the decimal, then your place value chart has been created. So if I have 215 and 6/10 and I need to shift everything, because it's multiplying, shift it left to greater positions 2 times, then I would end up with 21,560. Likewise, if I'm dividing, I'm going to go the other way, shifting the digits right, so that if it's a 2-position shift, this is where people will say, just move the decimal. Once you plop that decimal there, you have now created 2 in the ones place, 1 in the tenths, 5 in the hundredths, 6 in the thousandths. And so that's why you cannot just tack on 2 zeros here. Because if you just tack on the 2 zeros, you would end up with 215.600. And that's an equivalent number to this, which means you have not actually multiplied it by 100. And you would not get this answer, so that would be wrong. So anyway, these are the warm-up problems in the book before you get to lesson 2, which we're going to start right now and complete this. And there's a little bit, it's pretty challenging. There's a little bit of work that we have to do, and you can keep your place value chart handy as a cheat sheet, but we don't use it on this top part. So now that we've dumped off our place value chart, let's see if you understand the concept. 54,000 times 10, it's 54 times 1. Any number times 1 is that number. But how many zeros or place value positions are we going to shift? If you remember, in our previous notes, I said there is a shortcut way, and this is basically what it's going to look like. Don't be blurry. Don't be blurry. Oh, thank you. So if you multiply by 10, you're going to move digits 1 place to the left. This is on previous notes, okay? So you don't need to copy it unless you didn't get it before. If you multiply by 100, move digits 2 places to the left. If you multiply by 1,000, move digits 3 places to the left. And some examples. And then if you divide by 10, move digits 1 place to the right. If you divide by 100, move digits 2 places to the right. If you divide by 1,000, move digits 3 places to the right. It's a pattern. Watch those patterns. So since I'm multiplying, watch the signs. Write that down, okay, so you can be vigilant. Okay, if you're multiplying, we're shifting digits to the left. How many zeros are there? 1, 2, 3, 4. All 4 of those are going to be placeholders. 1, 2, 3, 4. Now that you have the digits that have value and the digits that hold places, you can put your comma in and you've got your final answer. So 54,000 times 10 is 540,000. So it's a shift of 1 position to the left. How about this one? 54,000, same starting number, but divided by 10. We're going to shift everything to the right. What happens if this goes to the right? Okay, my decimal would then be here because everything is shifting. This is going from 10,000s to 1,000. There it is in the 1,000s position. You can put a comma in if you like. Multiply by 10, 1 shift. 2 greater place value positions. 8 ones goes to 8 tens. 7 tenths goes to 7 ones. 8 and 7 tenths, shifting 1 position smaller. I put a 0 in there to tell you that there is no ones or tens or anything that's a whole number. Up to the top of the next. If I'm multiplying, again, watch those signs. I want the 13 to become 100 times bigger. So that means that if I shift it 2 place value positions, it's going to go, this is where people say, just move the decimal 2 places to the right and plop it in, you get 13. It's really shifting 2 positions with the digits. Okay, so actually that went too far in my little doodle. There we go. Okay, so you should end up with 13 ones. Divide 13 by 1,000. I need 3 shifts. Dividing means shift to the right. And I would end up with 0.013. Okay, if the decimal was here before, you have to move the digits 3 places to the right, which moves the decimal 1, 2, 3 places to the left. That's kind of why people say just move it, because it's harder to write it. Anyway, this is how it ends up. Use your place value chart. This one is a good example to use the place value chart, because if I start out with 13, okay, and you want to divide by 1,000, it's going to be 3 shifts to the right. So it would go like this: 1, 2, 3. Move that 1. Move the 3. 1, 2, 3. They always stick together. If it's 13 here, it's going to be 13. Make sure you don't have a gap. But this place here, because it has no digit, we have to connect with the decimal. The decimal is your anchor to holding the value of that number, okay? So that's why you have to put the 0 here. Let's continue. 3 and 1/1200ths times 1,000. So it's going to be shifting the digits to the left 3 times. So I still have the 3 and the 1 and the 2 together, but because they've gone from ones, it's going to go tens, hundreds, thousands. So you end up with 3,120. If you're dividing, you've got 2 zeros. So this is going to be shifting my digits to the right to be smaller. I'm going from the thousands place. It's going to go how many shifts? 1, 2. So I'm going to have 4. Look at the digits in order. 4, 0, 3, 1, 2, 4, 0, 3, 1, 2. Where's the decimal? It's going to be right here. And when you shift, the 4 should go from the thousands place to the tens place. Okay, now that you have 4 in the tens place, all the other digits line up as they were. So that's our big idea for this lesson. When it says find the products for number 2, we're using the same factor, but just showing what happens when you look at that pattern. So this one's pretty straightforward and easy because this is a whole number. So I'm going to take my 19,340, don't put the comma in, and multiply by 10. We simply can shift them 1 spot to the left, so I get 193,400. If I multiply by 2 zeros or 100, it's still 19340 is my first factor, 0, 0. Then do 1, 2, 3, 1, 2, 3. That's how you put your commas in. And this one, 19,340 is your factor. Don't forget this 0 here. That is part of our first factor. Times 1,000, 1, 2, 3. Now put in commas, 1 and 2, because you go 1, 2, 3, 1, 2, 3. Remember, it's ones, tens, hundreds, comma. Ones, tens, hundreds, comma. Now, this has an explanation. Explain how you decided on the number of zeros in the products for A, B, and C. So let's take our 19,340, multiply it by 1, 19,340. Okay, so the first factor has a 0. Okay, you have to pay attention to what that full factor is. Okay, then I shifted the digits for each 0 I multiplied by. Shouldn't end a sentence with a preposition, and yet I'm going to do it. Okay, so for example, times 10 equals one more 0 after 19,340. Okay, so that equals 193,400. And so that's your explanation there. If you have times 100, it's 2 more. Times 1,000, it's 3 more. Okay, and you can continue and show if you wish. But I'm going to turn the page. All right, same kind of thing, but we're doing division. Find the quotients. So if I have 152, and this is a whole number, and this is ones right here, if I divide by 10, because we're going to watch out for the signs, that means I'm shifting to the right. And the right means that my number's getting smaller. So if I have one shift, I'm going to end up with 15 and 2/10. If I have 2 shifts, I'm going to have 1 and 52/100. If I have 3 shifts, the entire thing is shifting over, and I have 152,000ths. Now, how do I decide where to place the decimal here? So when I divide by 10, that equals 1 shift right for the whole number. Okay, so you can show on a place value chart if you need to. If that helps you, you should write out your place value chart. If you divide by 100, that equals 2 shifts, right? Again, include and be specific which direction you're going. Divide by 1,000, that equals 3 shifts right. Division means shifting the digits right. If you want to call moving the decimal, you would move the decimal left. I hope that doesn't confuse you, but you really do. If you put the decimal to the left, it makes your number shift to the right. Okay, it's kind of 6 of one, half dozen of the other. Some students will say, just move the decimal, and whatever's easier for you, okay? But if you shift the digits right, then the digits have smaller value. Okay, Janice, she's so funny. Janice thinks that 20/100ths is equivalent to 2,000ths because 20/100ths is equal to 2,000ths. Use words and a place value chart. So you have to set up a place value chart here to correct Janice's error. Janice, don't make that mistake. Why don't you put your decimal down first and then do tenths. Oops, I'm going to do hundreds because it's faster, and thousandths. I'm going to make some columns. Again, I like to put my decimal right on the line. Ones, tens, hundreds, thousands, a combo for all you fun people out there who love to keep things the same. Mixing it up. Okay, so Janice is looking at this chart and she's saying this decimal value is equal to this decimal value because she's got proof. 20/100ths is equal to 2,000ths. Okay, so if I have 20/100ths, I have 100 times 20. 1 times 2 is 2, and 1, 2, 3 zeros makes 2,000. So 20/100ths. Okay, 20/100ths. That really is 2,000. 20/100ths really is 2,000. Okay, 20/100ths is 2,000. Hooray! Good job, Janice. Good job, Janice. Okay, then let's prove that there's an error here. 20/100ths. What does that look like? Okay, well, I'll show you. 20/100ths is going to end here. 20/100ths. looks like that. But 2/1000ths does not look like that, okay? This is what I say, not equal to. 2/1000ths is 0/10ths, 0/100ths, and 2 in the thousandths place. This is going to, it's kind of leading you into how to read decimals as we get into them in later units. So reading decimals correctly, this is 2/1000ths, this is 2/10ths, or 20/100ths. I say 20/100ths because the 0 is in the hundredths position. I say 2/1000ths because the 2 is in the thousandths position. I could also call this 2/10ths and just leave it at 2/10ths. That is the same. Oops, my bad. 0 and 2/10ths is equal to 0 and 20/100ths because this is in the same spot. Okay, the 2 has value and it's in the same spot. So this 2/10ths is equivalent to 20/100ths, neither of which is equal to 2/1000ths. Okay, why? Because the 2 is way over here. It's in the thousandths place. Okay, so if you show on a place value chart what's happening, you can show Janice, this 2 does not have the same value as this 2. And if you look at your place value chart from the introductory to place value positions video, that's exactly what we were doing with the 1s. Okay, if the digits are in a different column, they have different value. I hope that's clear. We're going to move on. Last problem, Canada has a population that is about 1/10 as large. Canada is 1/10 as large as the U.S. If Canada's population is about 32 million, about how many, oh, there go the lights. Hey, that's just like lesson 1 video. Woohoo. If Canada's population is about 32 million, about how many people live in the United States? So if I want to find out the United States, but Canada is only 1/10 as large, then I would take what I know, which is Canada's number, 32 million. I'm going to write this out in place value positions. And I want to know what the U.S. has. Well, if Canada is 1/10, then the U.S. is 10 times that. Remember, in the previous video, I said multiplication and division are inverse operations, okay? They do undo and redo. They're the opposite. So if Canada is only 1/10, then I need to multiply by 10 to find out what the larger one would be. Now, how do I figure out how many zeros? Well, I'm going to take my 32 million. I'm going to multiply it by 10, which gives me 1 shift to the left, which means my 3 in the 10 million spot and the 2 in the 1 million spot will go to the 100 millions and the 10 millions, and I'll move this 0 over into the 1 millions there. 100 million, 10 million, 1 million, comma, thousands period has zeros, the ones or units period has zeros, and so the population of the United States would be about 320 million, which is 10 times the amount of the population of Canada. So there you go. Explain the number of zeros, and I would write shift 1 time to the left, so that the 32 shifts to the 100 million and 10 million. That leaves, instead of 6 zeros, I have 7 zeros. That gives me 7 zeros instead of 6 zeros. And there is your very complete answer for the end of lesson 2. And I hope you learned something on this video, and good luck on your homework. I'll see you on the next video. Bye.